Hello everyone. In this video, I am going to discuss the common collector configuration of bipolar junction transistor or BJT. So, this is the common collector configuration of BJT. In this common collector configuration, the collector terminal is common between the base terminal and the emitter terminal. So, we can see that here this is the collector terminal and it is sandwiched between the base terminal and the emitter terminal. And in this common collector configuration, the base terminal is the input terminal and the emitter terminal is the output terminal. So, in this common collector configuration, the collector terminal is always grounded, and we can identify the configuration of a BJT by identifying this ground. When it is common collector configuration, the collector terminal will be grounded, and when it is common emitter configuration, the emitter terminal will be grounded, and when it is common base configuration, the base terminal will be grounded. Now, when we consider the AC analysis of common collector, then all the DC sources will be removed, and this will look something like this configuration. And as a result, the collector terminal will be grounded. Now, when we apply the AC signal in the base, that is the input terminal, then our input current will be IB or the base current, and our input voltage will be VCB, that is the collector to base voltage. Our output current will be IE, that is the emitter current, and our output voltage will be VCE, that is the collector to emitter voltage. Now, this is the input characteristic curve for BJT common collector configuration. Here we can see that this graph is versus VBC, that is the base to collector voltage, versus IB, that is the base current. Now we know an equation, that is VCE, that is the collector to emitter voltage, is equal to VCB, collector to base voltage, plus VBE, base to emitter voltage. So if we increase the VBC, that is the base to collector voltage, this voltage, then the depletion region will decrease, and as a result the IB, that is the base current, will also decrease. And we can see as the VBC we increase, the IB, that is the base current, is decreasing from this graph. Now if VCB is fixed, this part is fixed, and we increase the VCE, and then the VBE will also increase. As this part is fixed, then VBE is proportional to VCE. So if we increase VC, then VBE will also increase. That means the base to emitter voltage will increase. And we know in the active region, the base to emitter voltage is forward biased. So as we increase the base to emitter voltage, the base to emitter terminal will be more forward biased. And that means more electron will pass through this base region. And this will increase the base current, that is IB. So if we increase the VCE, then we will increase the IB. That is, if we increase VCE, IB will also increase. Now here is some characteristics for common collector configuration. In a common collector configuration, the input impedance is very high and the output impedance is low. As a result, we can have a high current gain, but the voltage gain is low and the power gain is also low. Now, this is the output characteristic curve for a common collector configuration. This curve is VCE, that is the collector to emitter voltage, versus IE. And we can see that as the base current IB increases, the emitter current IE also increases. So IE depends on the base current. And we know an equation from this, my previous video, you can find those equations. And this curve, this straight line is not exactly straight, this is a little bit high. So we can see that the IE and VCE, from the IE and VCE curve, IE is not increasing in a straight line. So this is the output characteristic curve for common collector configuration. So thank you so much for watching my video. If you like my video, then please click the like button and please subscribe my channel. Thank you very much.